of this. Okay, I told you that when something is at equilibrium, there's going to be a ratio of products concentration and reactant concentration, product over reactants. And the expression is written like this: that it's the concentration of the products divided by the concentration of the reactants. The coefficient basically becomes the exponent. It NAC becomes squared क्योंकि वो दो दफा आ रहा है products में, and H2 becomes cubed. The 3 over here becomes the power. So the coefficient in the equation becomes the power. We did some expressions for Kc, and I told you that Kc was a constant. There's only one thing that changes the value of Kc, and that is temperature. Always a constant, irrespective of concentration or pressure, only affected by temperature. So the ratio of the products and reactants in the equilibrium is going to be maintained no matter what. अगर आप product कम कर दोगे, the reactant will make more products, and the ratio of the products to reactants that will be maintained. So that is what Kc is. So let's write an expression for just another. For another equation. Okay, I've got a reversible reaction, and that's what is that reaction? Just a second. यहाँ पे बस हमने देखे थे. Let me open the sheet as well for AS. कहाँ पे? अच्छा, the old worksheet, the Lee-Shatler principle worksheet. For example, I want to so this one we did some questions. Kc, this is the expression for Kc over here. Some other expressions, like if somebody is going to ask you for the Kc expression for this one, what is the Kc expression? It's going to be product concentration, so it's going to be CH3, OH, and its concentration, and water concentration, and the whole thing gets divided by the reactant concentration, which is CO2, and you've got H2, and that's going to be cubed. So that thing is going to be cubed. Some other expressions of this one we wrote that down too. If you have an equilibrium, you can write a Kc expression. We already did this. So anyways, you can write a Kc expression. Now about the Kc expression, one thing is about the values that it takes. Now remember this, that the Kc expression, the values that are going to be used, it's based on concentration. So the input is concentration. Yes, so you will be using concentration. Now remember, concentration, the term concentration only applies to either gases. So it only applies to gases or mostly to solutions. Now remember, concentration has to do with spacing of the particles. The gases can be more concentrated, they can be less concentrated. Like if you have fewer particles per unit volume, that's a less concentrated gas. Similarly, if you have the same gas, and that gas is, you have added more particles per unit volume, तो उस केस में क्या होगा? It's going to be a more concentrated gas, right? So you'll say that the gas is very concentrated. And secondly, the same thing applies to solutions as well. In solutions, the only difference is that you've got, the particles are suspended in a medium. So they're all suspended in a medium, and that medium is most of the time that's water. These higher particles, they're all So they're all in water. So the particles could be close together, the particles could be far apart. This is more concentrated, this is less concentrated. So gases, solutions. Because remember the term concentration only applies to gases and solutions. Liquid के लिए याद रखना for liquids, for any liquid, you don't have the term for liquids or for solids. Concentration is taken as a constant because the spacing never changes. So the concentration is considered to be constant, and it's usually taken as one. Why? Because the spacing of the particles, it never really changes. Now वो दूर दूर होते हैं यहाँ पे तो spacing change हो रही है ना gases के अंदर, they're becoming closer together. You've added, let's say, sugar to water. If you add too much of it, the particles would be close together. They'll be far apart if you add very little of it. So the spacing never changes. Liquids can be. If you have water liquid, right? Imagine that you've got water liquid. The liquid के अंदर क्या होगा? The particles are all kind of tightly packed. I mean, loosely packed compared to solids, but the particles are still like right next to each other. They're slipping and sliding. They might have tiny gaps between them, but they're still close together. They're sticking together. They're not like gases. They're not moving in all directions, right? Freely in all directions. They're not going away from each other. So they're kind of slipping and sliding past each other, but in liquids, the particles are still together. So is this clear? The idea clear? Or solids kind of the particles are always tightly packed. So is this idea clear that concentration term does not apply to liquids and solids? Is that clear? Munir, is this clear?
Yes, sir. Yes.
बाकी अहमद राफिक clear है सबको?
Yes.
Yes.
और ये कि तो कहीं भी water liquid होगा, you're going to take its concentration as one. The term concentration will not apply to it. So what do we do next? The next is you're going to get two types of questions about calculating Kc. और ये मैं थोड़ा सा एक एग्जांपल ले लेता हूँ कि इधर मैं ऐड कर लेता हूँ. Substances that are liquid and solids, they're not written in the expression. Like if you take them as one, then you're effectively not writing them in the expression. So these ones, liquids and solids, they are not written in Kc expressions. If I have a reaction, an equilibrium reaction, and the reaction looks kind of like this, it's copper plus Fe3 plus, and it's an equilibrium reaction, and what they end up forming is copper plus 1 and Fe2 plus. Now, if I were to write the Kc expression, the first one is a solid. Its concentration will be constant. It will not change. The others are aqueous signs. So anything aqueous, its concentration will change. पानी के अंदर आप चीज ज़्यादा डाल दो, they'll be far apart. ज़्यादा डाल दो, they'll be close together. Less moles per unit volume, they'll be far apart. So if I were to write the Kc expression, it's going to happen like this. It's going to be copper 2 plus concentration aqueous. Square brackets is for concentration. The other product is Fe2 plus. And what are my reactants? My reactant is copper solid. Its concentration, and Fe3 plus and its concentration. Now, one of them is not going to be written in the expression, and that's the copper, which is solid. That will not be written in the expression. Why? Because solid की concentration जो होती है, that's 1. Is that clear, this thing?
Yes, sir.
So the rest is now we're going to move towards calculation. So just a little, there was just a small point that that concentration, just keep remember this, concentration only applies to gases or solutions. For all the rest, it's taken as a constant. Okay, and this spacing never changes. So now you're going to get questions like this. So for example, this is your calculation questions now. And this is, let's call that type 1 question. So question type 1. Now the question is that, so here's the question that you've got, let's say 0.5 moles of N2. And this question is about calculating Kc, finding the value of Kc. So the question is like this, that 0.5 moles of N2 and 0. Let's say 6 moles of H2. And 0.3 moles of NH3. So 0.3 moles of NH3 are mixed in a container. And the container has a specific value, that's a 1 neem cube container. Right? So that's those are known as your initial moles. Like these things are mixed together, and those are known as your initial. Those are known as your initial moles. Now at equilibrium, okay, the question will be written like this: that after several days, equilibrium has been reached. So they've allowed the mixture to reach equilibrium. Initially, it's not at equilibrium. So after several days, equilibrium is reached. The container now contains. So our container now contains 0.55 moles of N2. Zero 0.55 moles of N2. And they're asking us find Kc. So you're being asked to figure out what the value of Kc is. So based on the data, how are you going to do that? So you're going to make a table first, and you're going to write the reaction. Let's assume that the reaction is already written for you. They've told us that the reaction between N2 and H2 and NH3 is this one. It's the Haber process reaction. It's N2 reacts with H2, and it's going to be in equilibrium with 2NH3. So that's a reaction. We already know the reaction. Now every time it's going to be solved in this way. There's going to be you're going to make some rows. TK, let's say that's your first row, and let's make 3 of them. So that's over here my second one. And I've got another one, the third one. So that's the third one. And I'll add a column over here. So I guess that's about it. And maybe another column over here. Okay, so we've got N2 and H2, and they are in equilibrium with NH3. So let's try and fill this up. Now, every time the first row will be your initial moles. So that's your initial moles. That's the stuff that you've added initially, right at the beginning. So what were the things that you added into the container? You added 0.5 moles of N2. So initially there was 0.5 moles of N2, right? And you added 0.6 moles of H2 as well. So your container had 0.6 moles of, remember right now the reaction has not started. You just added them up, you mixed them up. And you added 0.3 moles of NH3 as well. So इसके ना 0.3 moles वो भी add कर दिए इसमें, ठीक है? So that's the stuff that you put in the container, right? Those are your initial moles. Those are the things that you mixed into the container, right? So 0.5 इसके डाले, 0.6 इसके डाले, 0.3 इसके डाले, and you just mix them together, right? Now, and then you closed it for several days until equilibrium is reached. So after several days, equilibrium is reached. So you allowed the reaction to happen, and maybe अब क्या हो सकता है? So when you mix them together, right? Maybe there is some forward reaction, right? So the amount of N2 and H2 will decrease, and the amount of NH3 will decrease. Maybe there's some backward reaction. So if there's more backward reaction, then the amount of N2 and H2 will increase, and the amount of NH3 will decrease. But after several days, there would come a point when the rate of forward reaction and the rate of backward reaction would eventually become equal. So at that point, there's going to be equilibrium. Now, we don't know where that equilibrium gets reached. हो सकता है उस point तक ना there's more NH3 being produced, like there's more forward reaction happening. So the amount of NH3 will become greater and the amount of N2 and H2 will be lesser. Yeah, ho sakta hai there's more backward reaction happening and the amount of N2 and H2 will increase and NH3 will be lesser. But at the end of the day, an equilibrium is being established, ठीक है? तो ये idea clear अभी तक? Unair, is this clear? Rafib, Ahmed, Ibad, is this
Yes,
clear?
yes, sir. Yes.
Now, we don't know where that equilibrium gets or what is the point when that equilibrium is reached, right? But they gave us a hint and they told us that after several days, when equilibrium has been reached, the container now contains 0.5 moles of N2. So I'm going to use the bottom row, which is these are my equilibrium moles. So after several days, when they actually opened the container and they found, so what they found was that the amount of N2 now is 0.55 moles. And that's the only hint that's given, that they've told me the equilibrium moles of N2. So what does that mean? Initially you added 0.5. Now you've got 0.55. So that kind of means that there must have been some more backward reaction or forward reaction. क्या होगा when you mix
Forward.
अगर forward होता the amount of N2 would have
Backwards, sir. Backwards.
it would have been more backward reaction, right? Because the amount of N2 is actually increasing, right?
Oh, okay, sir.
ठीक है? And by what amount? That means the time it took for equilibrium to be reached, 0.05 moles of N2. So 0.05 moles of N2 have already been produced. An extra 0.05 moles. So they've been produced. Is that clear?
जी sir.
Yes.
Okay, एक ये produced हुआ है, so this would be 3 moles of this will be produced, right? I mean, this will not get produced. I mean, this is the middle column is the one where you apply the ratio. Because remember, the top one you can mix. Remember this: the top one you can mix the moles in any ratio. But a container tha na, you could have mixed 0.8 moles of NH3. You could have mixed any moles of NH3, right? So the initial moles that you add into the container, they don't have a specific ratio. You can just put any amount into the container, right? It's the middle row where the ratio gets applied, because that's the place where you figure out what is the reaction happening. Do the particles react, or are they getting produced? So 0.05 produce हुआ है. 0.05 produce करने के लिए you should have 1.5 moles of 0.15 3 times more. To produce 0.05, according to the ratio, 0.515 moles of H2 must have also been produced. Because N2 is not going to be produced in isolation. If you produce N2, 3 times as many H2 will also get produced. So is this idea clear?
जी सर.
So based on the data, we figured out that 0.05 moles are getting produced. And using ratio, I was able to figure out that iski bhi phir 0.15 3 times more. 3 times more will be produced, right? And how much LST must have reacted then? Okay, 1:2, right? So if you want to produce 1, you should react 2 LSTs, right? So if you want to, तो कितना होगा?
0.1, sir.
0.1, that's going to be 0.1. So that means 0.1 NHT must have reacted. So they only gave us this information, which is this one, that 0.05 moles got produced. They didn't even tell us. They just told us that कि भाई शुरू में डाला था 0.5. Now you've got 0.55. So we figured out that भाई 0.05 extra produce हो गए. So 1 got produced, 3 of this will be produced. So 0.05, so 0.15 of this will be produced. To produce 1, 2 should react. So to produce 0.05, 0.1 should react. So यहाँ पे क्या हो रहा है? 0.1 moles are reacting. So they reacted actually. Now I'm going to complete the last column, which is the equilibrium moles. इसके तो उसने खुद दिए हुए थे ना 0.55. You added initially 0.6 moles. 0.15 moles extra got produced. So how many total moles do you have at equilibrium now? That's going to be the sum of the two. It's going to be 0.6. शुरू में the container had 0.6. 0.15 extra got produced. So now you've got what? 0.75 moles? Is that correct?
जी सर.
अच्छा ये कितना शुरू में डाला था initially? You added 0.3, right? And out of that 0.3, 0.1 moles have reacted. So they're gone. So you're left with what? You're left with 0.2 moles, right? Is that clear?
जी सर.
Sir,
Yes.
just a question, sir. How did you determine which one is getting produced and which one is getting reacted, sir?
Nee, because initially we had 0.5, right? And in the question, he gave me 0.55 of this, right? So that means the reactants are getting produced, right?
Yes, sir.
And there's more backward reaction. I mean, this must be reacting then. Is that clear?
Okay, sir. Fine.
Okay, 0.5 से 0.55 हो गया था, ज़्यादा हो रहा था. अगर कम होता ना, then I would have said that this is reacting, right? If this had been 0.45, then it would have been the opposite. That then I would have suggested that 0.05 have reacted and the reaction has gone in the forward direction, right? So anyways, the main task for all of this was that you had to figure out equilibrium moles, because Kc is calculated for equilibrium, and we have the equilibrium moles. But remember, for Kc you need concentration. You don't need moles. You need concentration. Be careful about that. So don't use moles in Kc. Use concentration. That's why I gave you a 1 dm cube container. So how do you find concentration? It's going to be the same thing. It's going to be, I mean, you got a 1 dm cube container, so it's going to be 0.55 moles. So that is going to be mole per dm cube, right? 1 dm cube. The other one is 0.75. And this one is 0.2. moles per dm cube, right? Is that clear?
Yes, sir.
Yes, sir.
अब क्या करना है? You just write the Kc expression. What's the Kc expression for this? It's and remember Kc is calculated for equilibrium moles. I mean Kc is for equilibrium. In this case, it's going to be NH3 concentration squared, and the whole thing gets divided by N2 concentration at equilibrium times multiplied by H2 concentration, and that's going to be cubed. So that's my Kc expression. I'm going to plug in the values. So what are my values? It's NH3 is 0.2 squared, and what are the other ones? N2 is N2 is 0.55 times the other one, which is 0.75, and that's cubed. Is that clear?
Yes,
The value bता दो इसकी.
Sir,
Yes.
when substituting the values into the equation, do we go based on the chemical equation or do we go based on the part we deduced about what the reactants are and what the products are?
Yeah, I didn't get your question. Which values are you talking
No,
about?
because based on our deduction from the table, we said
Yeah.
that N2 and H2 are the ones being produced and NH3 is the one being reacted.
Yeah.
So when we use the formula, do we consider NH3 as a product or reactant?
That's that thing. No, you go by this thing, like how they write the reaction.
Ah, okay, okay.
I mean, the one on the right side, that's your product. That's always going to be your product, and the one on the left side, that's going to be your reactant. So, I mean, equilibriums shift right. They shift left. In this case, it's shifting left, right? I mean, the amount of N2 is increasing, but that doesn't really matter. It's, I mean, the product and reactants are not switching. So by convention, I mean, conventionally speaking, the convention is the right one is always the product, the left one is always the reactant. Is that clear?
Okay, sir.
So did you even calculate the answer? What's the answer for this?
point 172.
It's 0.172. Are you sure? Okay. Just don't make a mistake over here. You get 0.1. Actually, it's 0.172. And you know what the unit is? It's x squared x to the power 4 x to the power minus 2. So it's mole per dm cube power minus 2. Mole minus 2 dm6. We did actually calculate the unit earlier as well. So that's going to be my unit. Mole minus 2 dm6. Concentration squared divided by concentration multiplied by concentration cubed. इसका जो unit है ना, we did calculate the unit for Kc. This one for NH3. I told you it's concentration squared, concentration cubed. I just told you that take concentrations x, simplify first, you get x minus 2, and then put x, what is x mole per dm cube, and that's it. ठीक है, is that clear?
Yes, sir.
Yes, sir. Yes.
अच्छा, अब ये कि we'll just directly move to past paper questions. Just remember कि solid. So that's question number, the first type of question. We're going to try and solve these questions. Just remember that solids and liquids, they would be taken as one. So I would have to open a different worksheet for Kc. 1 second. So let me just try and The previous one, I think I've already solved. 1 second. Let me just open it again. So let's try and do this question. We've got a question which says that and just hold on a second, it's hanging up. Actually, we've got this question. It's H2. I'm just going to write it bigger over here. H2 plus I2. And it's an equilibrium with 2HI. So my initial moles, what are my initial moles? I'm not going to draw the table. It's just going to waste time. What are my initial moles? 2 moles of hydrogen gas. So 2 moles of this. And 3 moles of iodine. So he's adding 3 moles of iodine were heated together in a sealed container. So he's not adding anything else. So that means initially there's no HI. Is that clear?
Yes, sir.
Yes, sir.
And then he'll give me some information about the equilibrium condition. Like it's going to reach equilibrium. So he's saying that it's allowed to reach equilibrium. The container had a fixed volume of 1 dm cube. At equilibrium, there were 2.4 moles of iodine. So he's saying that once it reaches equilibrium, you had 2.40 moles of iodine, right? So what does it mean? Did the equilibrium shift forward or did it shift backwards? You started with 3 moles. क्या हुआ है? कम हो गए.
Yes, sir.
Forward, sir, forward.
So that means the equilibrium, once you mix them together, the equilibrium slightly shifted forward. So how many moles reacted? 0.6 moles reacted, right?
Yes, sir.
So, and remember, I told you that ratio is पे apply होगा, ठीक है? So 0.6 moles reacted. So 0.6 moles of H2 must have reacted as well. It's 1:1, right? Is that clear?
Yes.
Yes, sir.
And 0.6 will react with 0.6 to produce double the amount, which would be 1.2 moles, right? I mean, is that clear that 1 reacts with 1 produces 2? 0.6 will react with 0.6 and it will produce 1.2. Is that clear?
Yes, sir.
Yes, sir.
So अब ये कि you started off at 2 moles. 0.6 are gone, so you're left with how many moles? 1.4 moles. You started off with 0 moles and 1.2 moles extra got produced. So how much moles do you have? You've got 1.2 moles, right? So you finally figured out the equilibrium moles. The concentration is going to be the same because it's a 1 dm cube container. So dividing by 1 will pretty much give you the same value. What is the Kc expression over here? The Kc expression will be, it's going to be HI concentration and that's going to be squared. And it's going to be H2 concentration divided by I2 concentration. So it's going to be 1.2 squared and divided by 1.4 times 2.4. तो बताओ कि क्या वैल्यू आ रही है?
0.429.
So we're getting 0.429, ठीक है? Is that clear?
Yes, sir.
Hunayt, clear this one?
Clear, sir.
Actually, the other one is that the first one, it's just about Kc expression. So that's going to be this one. I mean, NHC squared divided by N2 into H2 cubed. So it's they're being multiplied. Now this is kind of the same. It's the same exact question with different values. So you have H2 and I2, and it's an equilibrium with 2HI. So the initial, what are the initial moles given to you? You're given 0.2 moles of H2 and 0.15 moles of iodine, and you're given you're given 0.26 moles of HI. I messed it up. Initially, what does the question read? It says 0.2 moles of hydrogen and 0.15 moles are heated. So you just have these two. You don't have any HI initially. वो बाद में form हुआ है. Once and the equilibrium was established, the equilibrium mixture is found to contain 0.26 moles of HI. So at equilibrium, at equilibrium 0.26 moles of HI got produced, right? So ये बताओ कि where did the equilibrium shift, forward or backward?
Forward.
Forward.
Yeah, because you had 0, now you got 0.26. That means an extra 0.26 got produced, right? So how much H2 and I2 must have reacted if 0.26 is getting produced?
0.13.
2:1, right? So 0.13 over here must have reacted. And 0.13 of this must have reacted as well. So कितना बच गया? 0.15 में से 0.13 is gone. 0.15, 0.13 is gone. So you're left with 0.02 moles, right? और
जी
यहाँ
सर.
0.2 में से 0.13 is gone. So you're left with 0.07 moles. And you've got so that's about it. Now, so you found your equilibrium moles. Can you find the concentration now? अच्छा ये तो clear है ना सारों को?
जी सर.
Yes, sir.
अच्छा, can you find the concentration? I mean, you found moles. Can you find the concentration?
No sir.
No volume, sir.
No volume, right? Now remember one thing. You can take the volume as V. If I write the Kc expression for this, it's going to be HI squared, right? So it's going to be 0.26 divided by V, and that's going to get squared, right? And then divide by 0.07 divided by V, and 0.02 divided by V, right? Will the V get cancelled out?
जी sir.
Because top पे V squared and bottom पे you also have V squared, right? So the V kind of gets cancelled out. Is that clear?
जी sir.
So in this specific case, you don't actually need V, right? What are the units for Kc in this case? Concentration squared divided by concentration into concentration. So what is the unit that you get?
Nothing.
Nothing. You get no units, right? तो एक point note कर लो कि specifically when Kc has no units. अच्छा, so this one is specifically when Kc was the last point है, ठीक है, खत्म करते हैं. अच्छा, just remember this point that if Kc has no units, then what you can do is you can use moles directly. You don't need V because it's going to get cancelled out. Calculating concentration or concentration is not needed. ठीक है, concentration is not going to be needed in this specific case to calculate Kc.
So, sir, the final answer for Kc will have the unit mole.
It won't have any unit. It's just everything gets cancelled out.
Oh, so it's just a number.
Yeah, it's just a number without any unit. No units. mole per dm cube squared, mole per dm cube, mole per dm, everything gets cancelled out. Okay, so remember this, in this specific case, I mean, it's fine, you can find concentration, but there's no need to find the concentration because the volume part will automatically get cancelled out. Okay, you clear?
जी sir.
So remember
Yep.
this, remember the last point that every time you want to calculate Kc, you need concentration. Except when the Kc has no units. तो उसके बगैर भी काम चल जाता है. ठीक है? Clear है?
जी sir.
चलिए कल फिर करते हैं इसको और further questions practice करते हैं. ठीक है?
Okay, sir.
Okay sir.
Okay, take care everyone. Allah Hafiz.
Allah Hafiz.